Hello. Welcome to the section on motion in space. In this section, we'll cover some topics that, if you've taken a basic physics class doing basic classical mechanics, you've seen some of these things before. These are the very basic notions. So let's assume we have a particle. So a particle with trajectory given by a vector-valued function r of t. All right? So this is a particle moving along this curve. It could be in the plane, it could be in 3 space, one or the other, or even more. Okay, so a few things we usually care about for a particle other than just its position. So let's say, let's put over here position, since this is the position function of the particle. Other things we care about are the velocity, for example. Right? So the velocity of the particle is just the derivative of the position function. Right? So let's call that v of t, and this is just r prime of t. Okay? Again, just the derivative of the position. Well, the next thing is the acceleration. Right? The acceleration is just the rate of change in velocity with respect to time. So of course, we'll call this a of t. So the acceleration is just v prime of t. But using the fact that v of t is r prime of t, we can write a as r double prime of t. Right? Now, since we're moving around in 2 or 3 dimensional space here, but just in general, velocity is a vector. But if you think of when you're driving your car, it reads out some speed in miles per hour, kilometers per hour, whatever country you happen to be in, basically. So velocity is different from what you read on your speedometer, which is speed. But they're very much related in that speed is just the magnitude of velocity. So we're going to write here for speed, we're going to write this sort of funny looking v. It's actually the Greek letter nu of t. So this is what we'll use for speed, and this is just the magnitude of the velocity vector.